Okay, good evening, everyone, and welcome once again to Amateur Astronomers Incorporated, the astronomy club here at Sperry Observatory in Cranford, New Jersey. Our presenter this evening is Dr. Clif Ashcraft, who is a longtime member of AAI, and the title of his presentation is Exploring the Local Supercluster. And with that, Clif, you can begin.
We've all been exposed to lots of billions of light years in the news from the James Webb Space Telescope. Well, I'm going to deal with more in our own backyard, only the 200 million light year space around our galaxy, which we call the local supercluster. But I'm going to show you how that local supercluster fits into the universe as a whole. This is the big picture. This is the universe as seen by the Sloan Digital Sky Survey, 2-mass extended survey called EBOS. This is a picture of galaxies so far away that the light left over 12 billion years ago. Now, the fan-shaped thing, the universe is not shaped like this. This is a cross-section of all the sky accessible from Arizona, where the big telescope is that they took the data. And you can't see out through the plane of the Milky Way, too much gas and dust and stars in the way. And from Arizona, you can't see stuff down near the South Pole. So it doesn't make a perfect sphere, and this is a cut through the figure of the universe that is accessible to that telescope. Now, the James Webb telescope goes back quite a bit further. It can see galaxies back to 13.4 billion light years away, and the light left those galaxies 13.4 billion years in the past. Now, if I zoom in to a redshift of 0.15 or about 2.7 billion light years, you can see the filamentary structure of the universe composed of strings and clumps of galaxies called clusters of galaxies and superclusters. This is called the cosmic web. Now, look at the central region, only 2 billion light years across. Let's blow it up. Now you can see that these filaments are broken up into discrete clusters and superclusters of galaxies. For example, this is the Centaurus supercluster here, and right in the middle is one that we're going to be concentrating on tonight. It's the Virgo supercluster. You are here, by the way. You're nearly in the middle of the Virgo supercluster, and these things are pretty far away. You can see them in the big telescopes. Right in the center, this rectangular area, is something called Laniakea. Laniakea comes from a Hawaiian word meaning immense heaven. Now you can see that 4 of those strands of the cosmic web come together right here, and our supercluster, the Virgo supercluster, is right at the intersection of those. The Laniakea contains 5 superclusters, 100,000 galaxies, and it's 520 million light years across, and it includes the superclusters Centaurus, Pavo Indus, the Southern supercluster, the Hydra supercluster, and the Virgo supercluster. That's our home right there. I circle it in this, or I've ellipsed it in this red ellipse, and the other ones are the Pavo Indus, the Centaurus, the Hydra, and the Southern supercluster. But I'm going to be exploring this region with you tonight. This is a less detailed view of the clusters in the Virgo supercluster. Again, the local group containing our galaxy is right in the middle, And the big heavyweight in our supercluster is the Virgo cluster. I'll be showing you a lot of the galaxies in the Virgo cluster tonight, as well as in these other groups. Here is our local group containing the Milky Way right in the middle and a couple of other galaxies. Zooming in still further, here is the Milky Way with its satellite galaxies, the Large Magellanic Cloud, the Small Magellanic Cloud, and a bunch of tiny dwarf galaxies. And they're all more or less orbiting around the Milky Way galaxy. Now here's another view of the Virgo supercluster. You can see the Virgo cluster is the big heavyweight. And again, we're here in the middle. It's about 120 million light years across. And I'll be showing you some things far out on the edge of that that are right at the edge of our supercluster as well. The green dots that you see are I have explored on the in our supercluster. Some of the areas are inaccessible to me from New Jersey. I can't see much below the celestial equator, maybe 20 or 30 degrees below, before I run into trees in my backyard. Now, individual galaxies in these clusters are grouped together on the sky, but because of possible errors in distances, they may not actually be physical members of the clusters. For example, some of the things that are counted as members of the Virgo cluster may be way far in the background, or they may be a lot closer than we think, because measuring distances at galactic distances is hard to do. We're getting better at it all the time, but it's hard to do. Here's my spaceship. I'm going to take you with me through our supercluster. Oh, this is really a spaceship. This is my C-14 Schmidt-Cassegrain on a Losmandy G11 mounting, controlled with Gemini 2 Mini. And it's a very nice telescope. It points to wherever I tell it to point, and I can see surprisingly far away with it. Very much helped by this program called SharpCap, which allows me to do live stacking. So I don't have to take long guided exposures. I can take short exposures without having to spend a lot of time on automatic guiding, or worse yet, peering through an eyepiece, making minute adjustments to keep a guide star on a crosshair. Now, I also use this smaller telescope. This is an Astrotech semi-apo thing, only 70 millimeters aperture. But I use this for the larger objects simply because they won't fit on my camera at the long focal length of the C-14. Now here is the back end of my C-14. Attached to it is my camera. And this device in the middle is an extension tube that connects it to a focal reducer. I have F11 coming in from the Schmidt-Cassegrain, and I have F7 coming out onto the sensor, the CMOS sensor of my camera. The reason we do this is not only to give a bigger field, but to make it possible to have shorter exposures. It's like the f-stop on your camera lens. You go to the smaller f-stops to get more light so that you can have shorter exposures. Note the complete absence of either a guide scope, an off-axis guider, or an on-axis guider. I'm doing this by live stacking. Now, our first stop on the cosmic journey is the local group and its environments. This is literally our backyard. Right in the middle, you see the Milky Way. The big guy in our local group is M31, the Andromeda Galaxy. And there's a somewhat smaller one, M33, the Triangulum Galaxy. They're named for the constellation that they seem to be in when you look up at the sky. The Milky Way, our galaxy, is right here. Andromeda is the biggest, the Milky Way is the second biggest, and M33 is a distant third. And in addition to that, we have the Large and Small Magellanic Clouds and a bunch of tiny dwarfs. that are gravitationally bound to the local group, but they're very small little things. Roughly this blue egg-shaped thing is the boundaries of our local group. Nearby is the Sculptor group, and I'll show you a picture of this galaxy, but I haven't taken one myself because it's very low in the sky. It's in the constellation Sculptor, and it would be really down in the trees of my southern horizon. Now, here is a picture of our galaxy, the Milky Way galaxy. Well, we can only take a picture from the inside, and we're looking towards the center of our galaxy, and this is the Sagittarius arm, the spiral arm next in towards the center from us. There's one out further from us. I think it's called the Orion arm, but this is the Sagittarius arm. Now, you can recognize some constellations here. Let me flick it off. See this group of stars right here? That's the constellation Scorpius. And up here is the constellation Aquila, the eagle. See that group there? That's Aquila, the eagle. And down here is the constellation Sagittarius with the asterism in it that we call the teapot. Does it look like the teapot? And you can even see smoke coming out, steam coming out of the mouth of the teapot. Well, a very important thing is in Sagittarius. It's called Sag A star. That is the black hole in the center of our galaxy that everything revolves around. And it's recently been imaged by the Event Horizon Telescope. It's got 4 million solar masses in it, big heavy thing. And there's stars moving rapidly around it in the center of our galaxy. Now, this is what it would look like if you could get way up over the plane of the galaxy and look back down at it. This was constructed from radio astronomy observations, which can look through everything in the way and map out where all of these structures are. Our sun is right here, and we're looking through this small arm and at this big arm here, which is the Sagittarius arm. And in the wintertime, we look out that way through this arm of the galaxy. And above and below the plane of the galaxy, we can see way out into space and see the very distant galaxies. Here is the Large Magellanic Cloud. That's really about how far away it is. And the Small Magellanic Cloud. They're orbiting our galaxy, and probably tidal forces will eventually pull them into our galaxy, and their stars would just mix in with the stars of our galaxy. That's how galaxies grow, by the way, by cannibalism. Now, this is a diagram of the constellation Triangulum, and right next to it is the constellation Andromeda. And if you look at this direction in the sky, particularly with binoculars, you will see the Andromeda galaxy, M31, and the Triangulum galaxy, M33. Those are the other two big galaxies in our local group. Now, here's a picture I took of the Andromeda galaxy with that little telescope I told you about, the 70 millimeter f6 semi-apho. And this is M31 itself, and it's big and relatively close. It's about 6 times the size of the full moon in the sky. And with a typical 7 by 50 binoculars, you can't quite get the whole thing in the field of view if you've got a really dark sky. That's M110, Messier 110, and it's a satellite of M31. And this is M32, also a satellite of M31. These are elliptical galaxies. M31 and the Milky Way are spiral galaxies, although the Milky Way is a barred spiral galaxy. The light which image of M31 began its journey 2.6 million years ago. The genus Homo, to which Homo sapiens, our species, belong, was just a gleam in the eyes of a lovely Australopithecine Eve. Hey, Grandma. Now, M31 is on a collision course to the Milky Way and will merge with it in 5 billion years. And I sincerely hope that our descendants will have moved by then and can avoid the collision. Here's the little guy, M33, the spiral galaxy in Triangulum, also taken with that little telescope. There's a lot of Milky Way stars here in the way. All of these stars are foreground objects in the Milky Way. It's only this bright part here and this foggy part that's actually the spiral galaxy in Triangulum. Now, if you look out the other direction to the constellation Cassiopeia, you'll see, or rather you won't see, two objects, Maffei 1 and Maffei 2. These are actually members of the closest galaxy group to our own, but you can't see them because even though they're only 9.3 million light years away, they're obscured from view by dust clouds of the Milky Way in the constellation Cassiopeia. They're revealed by infrared imaging. They might show up in the near infrared. I'm going to try imaging that sometime. This is Maffei 1, which is an elliptical galaxy, and Maffei 2, which is a barred spiral galaxy. There's a number of smaller ones in the area, in the region too, but I did not include those. These will be great targets for the James Webb Space Telescope because it can use the mid-infrared and look right through all of the gas and dust and probably zoom right in on them and find regions of star formation and the like. This is, by the way, from the 2-mass survey image taken at 2 microns in the infrared. Now, this is an object that gets to be 15 degrees above my southern horizon. I might get it if I cut a few trees down, but I haven't been able to photograph it yet. But here is a nice picture of NGC 253 in the Sculptor cluster, which is in the Sculptor constellation. It's 11.4 million light years away. Credits to ESO for the picture that European South Observatory down in South America for this picture. Now, looking up north, there's a lot of clusters up here. There's all of these over here in the constellation Canis Venatici. There's these two up here far north in Ursa Major. There's this one, M101, and M102 over in Draco. But I will show you these constellations, these galaxies in detail. First of all, M81 and M82 and a couple of dwarf satellites form their own group. M81, also called Bode's galaxy, is 12 million light years away. And M82 is an active starburst galaxy, 11 million light years away. It's sometimes called the cigar galaxy. It sort of looks like a cigar. And if you look in the center of that, you can see streamers of hydrogen, ionized hydrogen gas above and below the plane. Something's going on with the black hole in the middle of that galaxy. It's very excited, and probably a lot of star formation going on. Now we look way to the south. These are some very difficult targets for me. We'll be looking at Messier 83, Centaurus A, which is, I have no chance of imaging that. And there's another one over here in Antlia. But here's the Centaurus A, the Centaurus A galaxy in a cluster. There's a few other galaxies in it. This one is a very powerful radio source, and it is the result of the collision of a spiral galaxy with an elliptical galaxy. Things haven't settled down yet, and it's got an active nucleus going on and blasting radio waves out into the universe. Can't see this from New Jersey. It's 4 degrees below the horizon. I can't even see it if I cut my trees down. It's one of the closest radio galaxies, so its active nucleus has been extensively studied. It's the fifth brightest galaxy in the sky, making it an ideal amateur astronomy target. However, you can only see it from very low latitudes in the northern hemisphere and from the southern hemisphere. It's got a 55 million solar mass black hole in the center, a lot heavier than ours. Ours is only 4 million solar masses. And this one, I might actually get to see this. It gets 10 degrees above the horizon, but I didn't take that. This was taken at the European Southern Observatory by a fellow named Robert Gendler. Now, these are pictures I took. These are in the Canis Venatici 1 group. The Canis Venatici is a hunting dog. This one here, M94, 16 million light years away, is a very interesting galaxy. The rotational velocities are fully explained by the luminous matter in this galaxy. It does not seem to contain any dark matter at all. This one is even stranger, M64. It's called the Black Eye Galaxy. It looks like somebody got a shiner. It's 17 million light years away, and it's got 2 populations of stars, one going this way and another one going this way. And they pass through one another without collisions because stars are so far apart. There's a few in this group that I haven't imaged yet. Those are targets for me to get later. Now, here's the big group. This is M101, and it has its own group of small galaxies associated with it. It's also called the Pinwheel Galaxy. It's got this little dwarf galaxy, NGC 5474, and it's in this direction, but a little further away. I couldn't put it on the screen. And over here in this direction is NGC 5204. It's another little dwarf spiral galaxy. You can see that this guy is already getting messed up by the tidal forces of this galaxy. But something exciting happened in M101 a couple months ago. A supernova went off. In fact, if I go back and forth, you can see this is a picture I took back in, I think it was last year sometime. And this picture I took on May 27th, 3 days after this was discovered by a Japanese amateur astronomer. That's the supernova. It was discovered by Koichi Itagaki on May 19th of this year. They found the star that exploded on Hubble images. It was 27th magnitude. And shortly after Itagaki discovered it, it got up to about 10th magnitude. And it peaked at 10.5. And that's where my first image of it starts. This was Itagaki's discovery image. These are images that were found on plates that people took before that, but didn't notice there was a supernova. And this is my first observation. I've been taking photographs of it and measuring the magnitudes on it, and it's decaying. But my last measurement, it was about 12.4, and I figure in about a month, it'll be 13th magnitude. It'll be around for a couple of years. Unfortunately, it's too faint to see except with a decent telescope. M102 group, this is another one of those groups way up in the the Draco constellation near Ursa Major. This is an edge-on lenticular galaxy, and this line you see here is the dust in the plane of the galaxy. Lenticular galaxies don't have definite spiral arms, but they're very similar to spiral arms. This is a spiral galaxy almost edge-on, 54 million light years away. And there's a couple more in that group that I haven't yet imaged. Now, further out, we have, well, actually not as far out as that one, the M51, the Whirlpool Galaxy. It's in Canis Venatici, and it's a beautiful spiral galaxy with a satellite that's about to collide with it. This is a celestial fender bender in the process. It'll take several several tens of millions of years for it to actually collide. But you notice that streak there? I mean, that streak is not an airplane. It's not a meteor. It's probably a Starlink satellite. I got photobombed by Elon. So, in the M51 is this very pretty galaxy. It's 27 million light years away, and it's called the Sunflower Galaxy because it looks like a flower. There's also NGC 5023 that I have not imaged yet, but it's part of this galaxy group. Now, there's another group called the Canis Finici 2 group, and it's got M106 in it, which is distinguished by being a type 2 Seyfert galaxy. That means it's got an active nucleus. Its black hole is having lunch. There's a jet coming out of it, and it's giving off a lot of light from the accretion disk around the center of it. Probably not a good place to be close to. Again, there's some more targets in that group that I haven't imaged yet. Now, Leo. There's a lot of stuff in Leo. There's the M95 cluster, and there's the Leo triplet over here. I'll first show you this is part of the M95 group. It's got M105 and two smaller galaxies in it. These are about 32 million light years away. Here's M95, which is part of that group, and it's a barred spiral galaxy. This is one that my son calls the TIE Fighter galaxy. And another barred spiral, M96, is also a member of that particular cluster. Now, the Leo triplet, which is a very popular thing for amateur astronomers to image, I have two pictures of separate members of that. The third was very far away, and I couldn't fit it in the field of view of my camera. Didn't have the little telescope set up yet, so I took all three of them and put them together to make this mosaic. So here's the three members of the Leo triplet. Now, the Leo is sometimes called the realm of galaxies, and here's why. If I only show you the Messier objects, here's the M95 cluster. There's the one that's got the Leo triplet in it. But if I now show you galaxies down to about 10th magnitude, you see a lot more of them. 11th magnitude, even more. 12th magnitude is really getting crowded. And if I show you all of the galaxies in the new general catalog, NGC, it is just galaxies from side to side. By the way, here's the Virgo cluster that we'll be talking about. It's just almost solid galaxies. But I showed you the Leo 2 and the Leo triplets. Lots of galaxies there. Most of them are outside of the local supercluster and probably out of reach of my telescope. Now, here is the M104 group in Virgo. M104 is this galaxy right here, and it is accompanied by these galaxies. Here's M104. This is called the Sombrero Galaxy because it looks like a Mexican hat. It's a almost edge-on spiral galaxy. Beautiful. And if you look at it in the infrared, you can see right straight through it to the other side. So most of the dust is in here, and these are mostly just a halo of stars. This was taken by the Herschel Space Observatory, whereas this one here, I took this with my C14. M104 is associated with NGC 4504, 4487, 4802, and 289, but it may not be gravitationally bound to them. M4504 is this nice little barred spiral galaxy. It's 4.46 million light years away, and nearby is 4487, another barred spiral galaxy, and it's 48 million light years away. Now, in the constellation Coma Berenices, this is Berenices' Hare, famous, I think she was a queen of Egypt. But there are a couple of clusters in this particular constellation. We have the Coma 1 group, which has this beautiful edge-on barred spiral galaxy. It's called the Needle Galaxy. And you can tell this is a barred spiral, not a regular spiral because of the shape of that nucleus. Even though we can't see it from the side, we know it's a barred spiral. And here's NGC 4725, another barred spiral. I think that looks more like Darth Vader's TIE fighter. Here is another galaxy in the Coma 1. It's kind of irregular. It might be a barred spiral, but it's a peculiar little galaxy. Now, again, looking far to the south, we have the NGC 2977 group. It's in the constellation Antlia. You know what Antlia is? It's an air pump. Not a mythological figure at all. They named this in the 18th century after the air pump was invented. But it's got this galaxy NGC 2997, but it's pretty far south, but I might just be able to reach it. It would be 9 degrees above the horizon, and it's a beautiful classic spiral galaxy. That's the one that I'll either have to go to a different place or cut some trees down to see. Now we get to the Virgo cluster. This is the heavyweight of the supercluster, and here is the brighter members of the Virgo cluster. And if you superimpose on it a chart showing all of the members of the Virgo cluster, you can see really how big it is. Now here's that chart magnified to show all the individual members. It's the average distance of these galaxies is about 50 million light years, and they're all in the direction of the constellation Virgo. Some of them might not be gravitationally bound. They may be on the other side of it, or they may be way closer to us. But there are about 2,000 galaxies in there, and they're scattered around in various subclusters. The largest concentration near this famous system M87, otherwise called Virgo A, is about 5 million light years in diameter. That's this region right here. Of the galaxies in the Virgo cluster, 58% are spirals, 28% are ellipticals, and the rest are irregulars. So most of them are spirals, but they're not the brightest members of the clusters. The brightest members are the elliptical galaxies. Now here are the 4 brightest galaxies in the Virgo cluster. Now, some of these images aren't that great. I obtained them with a rising almost full moon, and there's a lot of scattered light from the moon. But M49 is the brightest. M87 is probably the most famous, and M60 is famous for another reason. This is the brightest spiral. This one here is famous because in the little satellite galaxy NGC 4647 was a supernova. Back in 2022, another Japanese amateur, Koichi Itagaki, discovered that. I want to discover one of these, but I'm near missing most of them. This is a better picture of M87. I didn't use live stacking for this. I used lucky imaging, the same technique I used for taking images of planets, and that gives me higher resolution. You see this thing? That is a jet going at 99.9% the speed of light, shooting out of the center of that galaxy from the accretion disk around the gigantic black hole in the center of that galaxy. It's got a 6.5 billion solar mass black hole. And the accretion disk around that black hole powers that relativistic jet of plasma perpendicular to this. When they first started studying it with spectra, they thought it was going 6 times the speed of light. Einstein says, no, you can't do that. Turns out it's an illusion caused by the jet pointing in our general direction that makes you think it's going faster than the speed of light. The actual velocity is very close to the speed of light, but not greater than the speed of light. The shadow of the central black hole has recently been imaged by the Event Horizon Telescope. This is a composite radio telescope formed by the linkage of radio telescopes from all over the Earth, and it behaves like a gigantic radio telescope the size of the Earth. Well, they got this image of the shadow of the black hole. That's the shadow right there. You can't see a black hole, but this is the light from the accretion disk that's refracted around it by the intense gravitational field of the black hole. This is M100, the brightest spiral in the Virgo cluster. This is an image that I took. Again, you can see there's some moonlight in the picture. There's some dwarf galaxies in there, lots of little dwarf galaxies, mostly ellipticals and irregular galaxies. Now, the Virgo 3 group is this bunch over here. But this is the main Virgo cluster. The Virgo 3 group is over here. And they're smaller, mostly spiral galaxies extending off to the side of the Virgo cluster, and they're a bit further away than the average member of the Virgo cluster. They're mostly spiral galaxies. This one here, NGC 5746, is probably not in the cluster at all. At 99 million light years, that's practically outside of the Virgo supercluster. So this is probably not really in the Virgo 3 group at all. You can see these are all at considerably closer distances. That guy is really far away. I don't know how far that one is, but so this is probably on the other side of the Virgo cluster. It's about twice the size of the Milky Way. Now back to Ursa Major. There's two more groups of galaxies: Ursa Major Cloud South, this group, and Ursa Major Cloud North, this group. And with these, we're really out on the edges of the supercluster. NGC 3726 is 47 million light years away, and it's about 85,000 light years in diameter. It's a barred spiral galaxy. See the bar in the middle of it. This is the 3675 cluster. It's a spiral galaxy. Nice big central bump in the middle. I wouldn't be surprised if that was a Seyfert galaxy also. Here is a nice barred spiral, 4051, and these are all in Ursa Major Cloud South. Now, here's the galaxies in Ursa Major Cloud North, NGC 3651. It's 35 million light years away, probably a lot closer to us than the rest of the members. This is 3556. Looks disturbed to me, but it's a spiral galaxy. Looks like a lot's going on in that galaxy. It's a lot of irregular stuff. And this is another barred spiral galaxy, 56 billion light years away. This is one of my favorites, though. It's 85 million light years away. It's the furthest away member of that galaxy group. M109. It's a barred spiral. It looks very much like our galaxy, but it's about twice the size of our galaxy. But this is what our galaxy would look like if you could get really, really far away and look back at it. You see the bar in the middle of it, and this is like the Sagittarius arm that we would look through to see the center, and this is like the one we would look out through to see the Buffet group. Beautiful galaxy, beautiful example of a barred spiral. But it's past, it's further away. It's probably not a member of that group, just a line of sight grouping. And really far out. Remember this picture of M51 I showed you before with that I got photobombed by Elon Musk? Well, look at this little thing over here. What the devil is that? It's not dust on my lens or anything. That turns out to be a galaxy, a 16th magnitude irregular galaxy, 230 million light years away, called IC 4276. It is so far away that it's not only outside of the Virgo Supercluster, it's outside of Laniakea. It's way over this way, very far away. And that's the farthest thing I have ever imaged with my telescope. Anyway, I'm keeping score. These are the different groups that I've observed, and these are the galaxies that I've gotten images of, except for the orange ones. Those are the ones that I either can't reach because they're in the southern hemisphere or are so low on the horizon that I would have to overwork myself with a chainsaw to be able to observe them. The blue ones are the ones I imaged last year. The red ones are recent acquisitions, and the white ones are ones that I'm going after on nights that it's not too smoky from Canadian forest fires or light pollution. And of course, that very distant one, IC 4276, which is not part of any of these groups. Anyhow, that I'm done. I'm happy to answer any questions.
Yeah, I got a question for you, Clif.
Sure, go ahead, Bob.
Robert Gendler, I spoke to him quite a few times at NEAF. Does he rent time on that scope, or does he go down to actually use it?
I think he was either there or had a night assistant working for him. He took the image down that he was did too remotely. I don't know if he's actually there or not, but he.
Oh, all right.
That was 50 million light years away.
Yep.
Because you were able to get in your picture, do you have any idea? And so, I guess, any the size of it? It must be enormous. Just see a little bit.
I think it's a good size elliptical galaxy. I can figure it out. I do it in you know I know the diameter of the second part measured in my image, and if I know how far away it is and how big it looks, I can calculate how big it actually is. But I know it's a good elliptical galaxy, bigger than the satellites that are on it, but not as big as M7.
Anybody else have questions? Anybody on the phone?
I got another one for you, Cliff.
Yeah.
What kind of degrees of image does that 76 or 70 millimeter capture?
Let's see. It's about a quarter of a degree. Quite a whole. It takes two shots to image press on it. I can easier that I can't do it in my head.
All right.
Do you have?
Your voice is breaking up.
Yeah, it. We don't know exactly what it is. There have been recent theories that they may be black holes, but other things, right? It's composed called WIPs, massive particles, and the best candidates for is a particle that's